Hey, it's Mr. Hayes. We're back. We're going through AP Stats and the Statsmatics lessons. We're starting 6.2 now out of the practice statistics. And it is time to get a raise. So you as students picked out numbers. You had a number from yesterday. And my class had this following distribution, as you saw in the video. So again, each one of these is the top number is how much they're getting paid per day. So anywhere from $1 to $25. And then here's the probabilities down here on the bottom. So as you can see, lots of people down here at the bottom, one person up here at the top. As a reminder, the mean and the standard deviation from yesterday, the mean was $7.14 and the standard deviation was $6.04. So now, me being the benevolent dictator that I am, is trying to figure out how should I give all of my class a raise. So my first thought would be, hey, maybe I'm going to go through and give everybody $10 an hour raise. Wouldn't that be nice? Everybody gets $10. So that means the first thing that everybody goes through and does is that there's their raises. The old wages are on the top and the new wages are on the bottom. So $1 now gets 11, $7 now gets 17, 25 now gets 35. I know. Stop, please. I'm more than happy to do it. Now, the probabilities are still going to be the same. So the probability distribution is going to look similar, but then you're going to go ahead and go through and, it's just that all the wages are higher. Students are then tasked to go through and find the new mean and the new standard deviation. Some of them do those in tables where they multiply these out. And actually, you just find the expected value. You can multiply all these things out. The standard deviation, they can either do by hand or again, they can do on verbal stats, however they want to go through and do that. These are the new standard deviations, and mean. My new mean is now $17.14. And my standard deviation stays, apparently, at $6.04. And so that's what this next question will go through and ask. How did adding a constant affect the mean and standard deviation? Well, the mean had jumped to $10, which if you think about it, makes sense. So I did a little distribution over here. Okay, so notice here, this at the top is the old wages, the bottom is the new wages. And so everything just kind of got shifted over. So in fact, like here, if I line these things up, it's identical to the same. So that's why, the standard deviation doesn't change. The spread is not any different. It's just that these are now lined up about there. So since everything got picked up and moved, the mean's going to change since the values changed, but the spread hasn't. Notice here in my range, what's the distance between 1 and 25? That's 24. That's the same distance as the distance between 11 and 35. So not a big surprise there. Option 2, because again, being the benevolent dictator that I am, why just look at one way of doing things, right? So maybe I'll just double everybody's salary. So $1 becomes $2. 100% raise is not anything to, sneeze at. 10, et cetera, everybody's got double. So now you go through mean again, same thing. You just find the expected value of it. And you go through, and once you do the math, the new mean is $14.28, and the standard deviation is $12.08. Question is, how does that relate back up to here to the original? Well, what's going on? Both the mean and the standard deviation are multiplied. Notice 714 is now 1428. That's been doubled. Okay, 608 has now become 1208, or 604 has now become 1208. That's doubled. And so again, if we take a look over here, this is a scale model of it. So the $1 becomes $2, 5 becomes 10, et cetera, et cetera. You can see, and this is roughly lined up where it should be. So you can see that things are now twice as spread out. So the fact that the mean changes, nobody really surprised it. The fact that the distribution change or the standard deviation changes sometimes throws people. But notice here, I have a range of 24. Here now I have a range of 48. Now, interesting, the shape, I can scale this back, and these still kind of, basically line up if I can get the scale right. Okay, so the shape is still fine. But what ends up happening, everything else is just doubled. And so that's pretty much what we have you guys go through down here. So now the question is, which option would you prefer? As I've already let the cat out of the bag, as it were. I don't know if you can say that in the 21st century anymore. So the people on the bottom, the people who benefit most for option 1 would be the people on the low end, the $1, the $5, and the $7, because they're making much more. These numbers here are bigger than what's going on there, right? Now, the other question then becomes, what happens for the other one? So who makes more? Well, on the second one, $25 makes more here, and same thing for 15. $10 doesn't care. They get $20 either way, so they're not affected. Okay, but this does kind of show you the differences, and that's something that you have to kind of take into account if you're talking about increasing wages or et cetera. If everybody's getting the same amount, the difference between the low and the high isn't going to change. However, even if you're giving not necessarily 100% wage, increase in wages, but even if you're talking 5 or 10%, what will end up happening is that the data will start to spread out. Even though everybody's moving up, the disparity between top and bottom is going to get larger the further you go. So anyway, that wraps up the experience part of this. I will see you in a few minutes for the wrap up on the formalized part. Talk to you soon.